Welcome, my friends! In this video, we're going to be discussing section 1.2, which is titled Core Concepts. In this section, we'll discuss the core ideas and terminology that will be important for us throughout the entire class. So the first thing to talk about is the term distribution. The distribution of a variable is going to describe the possible values of the variable and how likely each value is to occur. Here's an example. So we have a data set here which lists the G number of a number of Grand Valley students, their favorite color, as well as their high school GPA. Let's answer a few questions about this data set. First, we are asked to describe an individual with respect to this data set. Typically, when you have a data set in a table like this, each row is going to represent an individual. In this case, the individual is going to be a student, so each Grand Valley student is going to be an individual. Next, we are asked to describe the distribution of favorite colors. Well, the distribution of a variable should describe the possible values of the variable and how likely they are to occur. Based on our dataset, there's really only 3 possible values for the favorite color variable. We have blue, green, and red. Blue is the most common because we had 2 students choose blue. Finally, we are asked to describe the distribution of high school GPA. If we look at the high school GPA column, we can see that the high school GPA of each student is mostly around 3.1 because we have 3 students that are right around 3.1, but 1 student is much higher at 3.97. All right, let's next talk about the difference between a population and a sample. In statistics, a population includes all of the individuals or objects that are being studied. This is a little bit different than you might be used to using the word population. Sometimes you think of the word population as being how many individuals live in a particular area, like the population of Michigan or the population of the United States. In statistics, we're using this term a little bit differently. We're going to choose a group of individuals that we would like to study, and we're going to let the population include all of the people or objects in that group. So an example could be all students from Grand Valley State University. That could be an example of a population. A sample, on the other hand, is going to be a subset of the population. So it's going to include some of the individuals in the population, but not all of them. So if my population is all Grand Valley students, then a sample might be one class of Grand Valley students. So if the population is represented by a big circle or a big oval, then perhaps the sample is some smaller portion of that. So the sample includes some, but not all of the individuals in the population. Now, if you were able to gather information related to all of the individuals in the entire population, and you were to start doing some sort of calculation based on those, then we would call that a parameter. A parameter is going to be a single number that describes the population. So an example could be the average or mean age of students at Grand Valley State University. So if I had all the students at Grand Valley State University, and I was to calculate the average age, that would be a single number that would describe the entire population. So the term to describe that would be a parameter. On the other hand, if you only have a sample, you don't have the entire population, so maybe you only have a class of Grand Valley students, and you go ahead and you do the same process. You calculate a single number to describe the population, then we would use a different term to represent that value. We would call that a statistic. So whereas a parameter is a single number that describes the entire population, a statistic is going to be a single number that describes just the sample. So for example, maybe I would have the average age of students just in one class, and that would be an example of a statistic. Now in most cases, you're going to be dealing with samples, because in most cases, the population is going to be quite large. There are, tens of thousands of Grand Valley students, or maybe if your population was all individuals in the United States, well then, you have hundreds of millions of people, right? So in most cases, you're not going to be able to gather data from everyone in the entire population. But if you were able to do that, then we would call that a census. So a census is a collection of data from all members of the population. But in most cases, this is going to be unrealistic, so we are typically going to be dealing with samples. All right, so here's an example to look at, and this one is from the Grand Valley text. The Kelley Blue Book retail price, which this is a website, if you're not familiar with this, that kind of estimates the value of a car. So the Kelley Blue Book retail price was estimated for a selection of 800 used 2005 General Motors cars. So the first question asks us to describe the sample. So maybe pause the video and just think about that for a second. How would we describe the sample in this situation? Well, the sample is going to include some, but not all of the individuals in the population. We may view the population as, we'll actually do that in the next step, but the sample here is going to be the 800 cars that we have basically gathered, right? This is not all the General Motors cars. This is just a sample of 800 of those cars. So we would describe the sample in that way. The sample includes the 800 2005 General Motors cars that we have collected. But how is that different from the population? Well, remember, the population is the bigger group from which we have sampled from. So presumably there's a lot more than 800 2005 General Motors cars. So the population would include all of those cars, right? All of the 2005 used General Motors cars. It's a good habit to get into to whenever you are describing a population to use the word all. If you're using the word all, then you're making it very clear that you mean all of the individuals in that group and not just a sample or some sort of subset. Okay, we described this in the last section, but kind of just reiterating this here, that the members of the population are what we call individuals, whether or not they be students or cars or houses or anything like that. And from the individuals, we collect the variables. So a variable is just a characteristic that can be collected from an individual. But now the further step that we're going to go here is we're going to say, well, there's actually two main ways that we can kind of classify variables. We can call variables categorical, or sometimes called qualitative. And that would be if they are just categories or attributes, like maybe like class major or maybe like your favorite color, things like that. So these are non-numerical, right? These are some kind of maybe like a word or a label that can be used to describe this type of variable. Whereas on the other hand, a lot of variables could be quantitative, or sometimes called numeric. And this could be something like the age or the GPA or something along those lines. Anytime that you have your variable represented by numbers, we would call that a quantitative variable. All right, I know that the textbook doesn't actually take this step at this point, but I'm going to take the further step to talk about some common ways that we can summarize quantitative and categorical data. So if we have quantitative data, meaning we have numbers, then the most common thing that we're going to do is we're going to calculate what we call the mean. So here's a quick example of that. Let's say we had the age of students in a class, so a very small sample of students in class. 22, 26, 24, and 20 are the ages of these students. If we wanted to find the mean, then we could simply just add up all those numbers and divide by 4. So something you've probably been doing since, I don't know, 6th grade or something, right? If you were able to do that, you would find that the answer is 23. We would say the mean age of the students in this very small sample is 23 years old. Now, what's going to probably be new for you here is the different symbols we're going to use to represent these values. So we're going to use the Greek letter mu, which is kind of looks like a U with a little tail on the left, pronounced mu, which represents a mean calculated based on an entire population. So if you did this process and you had, let's say, every single student at Grand Valley, then the proper symbol that should be used to represent this number would be the Greek letter mu. On the other hand, if you just had a sample, which is probably going to be more often the case, then you're actually going to use a different symbol. So instead of using mu, you're going to use an X with a bar on the top, kind of like a horizontal bar on top. And this is what we call X bar. So whereas mu is the population mean, we might call X bar the sample mean. Now, if we have categorical data, meaning it is non-numerical, then we oftentimes will summarize that by calculating a proportion or a percentage. So let's look at how that will work. Let's say we have a small data set here of colors. So these are categorical because these are non-numeric. We have blue, green, red, blue, and pink as the favorite color of maybe 5 different people. Let's say we want to find the proportion of these colors that are blue. The way you would do that is count how many blues there are, which there's 2, and then divide by 5 because there are 5 different values. And if we do that, we will get 0.4, or in percent form, 40%. Now, if we calculate the proportion based on the entire population, then we're going to use a letter p, a lowercase letter p, to represent that value. So we might say that lowercase p is the population proportion. On the other hand, the symbol p hat, with a little kind of caret symbol on the top, represents the proportion calculated based on a sample. So p hat is the sample proportion and p is the population proportion. So if you do this process, let's say for every single student at Grand Valley, and you find the proportion of blues for all the students, then you should use p to represent that. But if you just had a sample of maybe one class of students, then the proper symbol to represent this value would be p hat. All right, so let's go ahead and summarize some of the information we have talked about here. So recall that a parameter is a single number that describes the population, and a statistic is a single number that describes the sample. I'm not sure if I pointed this out earlier, but you can also line up the letters here. So parameter starts with P, and so does population. And statistic starts with S, and so does sample. So that's an easy way to remember that the parameter describes the population, and the statistic describes the sample. So let's summarize some of what we have talked about in a table. So we can have either quantitative or categorical variables. If you have a quantitative variable, then most likely you're going to be calculating the mean. There's lots of other things that you could calculate to kind of measure this data or summarize this data, but one of the most common things would be the mean. If you calculate the mean based on a sample, then it would be a statistic. And the common symbol that's going to be used to represent that is going to be X bar. If you have a mean based on the entire population, it's going to be a parameter, and we're going to use the Greek letter mu. On the other hand, if you have categorical data, then most likely you're going to be calculating the proportion. The sample proportion is going to be represented by p hat, and the population proportion is going to be represented by p. I highly recommend that you memorize this table. It's very important that we can differentiate between these different symbols, and they're going to be used throughout the entire class, so the earlier you can memorize this, the better. All right, let's go ahead and take a look at another example. John does not enjoy reading. Therefore, he only owns 4 books, none of which he has read. The table below summarizes the 4 books owned by John. So we have the book name, the number of pages, the year published, and the genre. And we have John over here, not very happy about his books. So the books he owns, quite a collection here. He's got the Lorax, he's got Harry Potter and the Philosopher's Stone. We have the Diary of Anne Frank and the Lion, the Witch, and the Wardrobe. So let's go through and answer a number of different things about this table. First, we are asked to identify the individual. Well, in this case, each row is going to be an individual, which is going to be each book. So we could say each book is going to be an individual. Then we are asked to identify the population. Well, the population is the larger group from which our sample was drawn from. But if you actually focus on what we have here, they tell us that John only owns 4 books. So this actually is the entire population. All books owned by John is the population. So we really just have a census of all of those books. Identify and classify each of the variables. Now, I'm not really going to consider the book name to be a variable since it's kind of uniquely identifying each of the books. I'm really going to just start with the other 3 here. So I'm going to start with the number of pages, which is, of course, quantitative. Those are numbers. We have the year published, which is also quantitative. And then we have the genre, which is going to be categorical. Then we are asked to find the mean number of pages. So to find the mean number of pages, we can just add up all the numbers of pages, and then we can divide by how many there are, which is 4. So if we grab our calculator here, we can see that if we take 64 plus 336 plus 96 plus 172, and we divide that by 4, since there are 4 different books, we get 167. So the mean number of pages is 167. And the proper symbol that we're going to use to represent this is going to be mu. Since we have a census of all the books by John, then we should be using the population value to kind of represent that, and mu is the population mean. Finally, find the proportion of books that are fiction, and then use the proper symbol. So if we look at the genres here, we have 3 out of the 4 are fiction, so we're going to use 3 out of 4, which is 0.75. And once again, we're going to use the population value to represent that, and the population proportion is just the lowercase p. All right, so here is a question for you to try. So consider the data set below related to a sample of Yoshis from Yoshi Island. See if you can answer some very similar questions about this. And question number 4, you're going to need to enter into the Blackboard quiz if you are watching this as one of my students in my class. So take a few minutes to go ahead and answer these questions, and I will be back to answer all but number 4 in just a minute. Okay, so for the Yoshis here, we have, for all these Yoshis here, hopefully you're familiar. Yoshi is the friendly dinosaur from the Mario franchise, and he's got a very big shoes, which is why we're looking at the shoe size. He got a really long tongue, so that's why we're looking at the tongue length, and they actually come in different colors as well. So if you didn't know about Yoshis, this is a Yoshi. So the first question asks us to identify the individual. Well, the individual is going to be represented by each row of the data set, so we could say each Yoshi is going to be an individual. They tell us that this is a sample of Yoshis from Yoshi Island, so kind of the idea here is there's probably a lot more than just these 4 Yoshis on the island. So the population is going to be all Yoshis on Yoshi Island. Once again, try to use the word all whenever you are describing a population. Next, we are asked to identify and classify each variable. So we have the color, which is categorical. We have the tongue length, which is quantitative, and we have the shoe size, which is also quantitative. Again, I'm not really going to consider this observation as a variable. It's just really just kind of uniquely identifying each Yoshi number. I'm going to skip number 4 for now and go right to number 5, which is find the proportion of red Yoshis from the sample. Well, if we look here, we have 2 reds out of the total of 4, so we're going to take 2 out of 4. That equals 0.5, and we're going to use the value or the symbol p hat to represent that because we only have a sample of Yoshis. So when you have a sample, we should use the sample value, which is going to be p hat. All right, the last thing that we need to talk about in this video is what is called the level of measurement classification for variables. So this is just one other way you can think about how to classify variables. And there's going to be 3 levels of measurement that we're going to discuss. Sometimes people talk about 4, but we're just going to talk about 3. So first we have the nominal level of measurement, which you can kind of think of nominal as just labels or names. The definition I'm giving here is that there is no natural ordering from least to greatest. It's typically going to be a categorical variable, and you should think of this as names or labels. So an example could be maybe the favorite food of a student, right? It wouldn't really make sense to order from least to greatest different foods. Like how do you order spaghetti compared to pizza, right? Like maybe you personally, like one more than the other, but there's not really a natural ordering to different favorite foods. So we might call that a nominal level of measurement. On the other hand, an ordinal level of measurement is typically going to still be categorical, but now in some sort of ordering of the variables is going to be possible. But subtraction is not really going to have significance, or it might not really make any sense at all to subtract the variables. So sometimes you might see, like on a survey, you have like agree, disagree, or neutral, those types of labels, right? So there's obviously some sort of some sort of order in those labels. Like agree is maybe like the best, and then disagree would be lower than agree. So there's obviously some kind of like order to those, but it doesn't really make sense to subtract them. Like how much better is agree compared to neutral? Or like maybe there's a strongly agree. How much better is strongly agree compared to agree? You can't really, objectively determine how much higher one is compared to the other. So we would say this is going to be an ordinal version of a variable. And then finally we have ratio, which for all intents and purposes in this class is mostly going to be the quantitative variables, right? This is where the ordering of the variables is going to be possible, subtraction is going to be possible, as well as multiplication. Even division can sometimes be possible, or is typically going to be possible here. And they're all going to have significance and are going to have like an objective meaning, right? So an example could be age, right? So age is going to be quantitative, and it would make sense to subtract my age from your age, and maybe I would say that you are 5 years older than me or 10 years younger than me or whatever the number ends up being, right? And I could also say that I am twice as old as someone else, right? Or, I could do all those sorts of comparisons. And that's what would make something a ratio version of a variable. Sometimes they also say with ratio that you have an absolute 0, meaning that when you say 0 for that variable, it really does mean 0, right? So there could be some cases where 0 might not actually mean 0. Think about like years or like certain ways you can measure temperature. So we're technically not talking about those here. We're talking about things where 0 really means 0. So let's just look at some examples because I think that's the best way to kind of differentiate between these two, just to see a bunch of examples. So let's look at some of those. So the first one here says the number of minutes to finish an exam. Well, that's going to be quantitative, and we could subtract between different values. We could talk about one person finishing in half the time as another person. So this is going to be ratio data. Let's look at the next one, the rank in the class based on GPA. So like the highest GPA, the second highest, the third highest, etc., right? And you might be tempted to say here that, okay, it kind of looks like we have numbers, so maybe this is going to be ratio as well. But that's actually not going to be the case here. You think of these more as categorical labels, right? First, second, and third. And it really doesn't make a lot of sense to subtract these, because if I take the third and I subtract the first, I get second. But what does that really mean? So subtracting these doesn't really have any significance, but we can put these in order. We have first, second, third, etc. So this is going to be an example of an ordinal variable. What about major in college? Well, major in college, that's going to be nominal. That's going to be a name or a label, really, right? So we would classify that as nominal. It's not going to make sense to order those, but they are still going to be, labels. So we could call that nominal. Age, I've already kind of mentioned this. That's going to be an example of ratio. It's quantitative, and we could take differences, take ratios. And then satisfaction level, unsatisfied, neutral, and satisfied. I already discussed this one as well. This is going to be an example of an ordinal version of a variable. Okay, so here's an example for you to try. Go ahead and see if you can classify each of these different as either nominal, ordinal, or ratio. And the very first one you're going to have to submit into the Blackboard quiz. So I'll give you a second to try that out, and then I will be back to do some of the answers. All right, so hopefully you've given this a try. So if a student can curl their tongue, that's kind of like a yes or no. So that's kind of like a label. That's going to be nominal. Letter grade in the class, that's going to be like A, B, C, D, E. So that's not quantitative, but they can be ordered. So we would call that ordinal. Number of hours worked per week, that's going to be ratio. And same thing with the arm span. That's also going to be ratio. All right, so I think that is all I have to talk about in this video. So I will see you in the next one.